Hello and welcome to class again. Thank you so much for staying. Thank you for liking. Thank you for your support. I really appreciate it all. Thank you so much. If you've not subscribed, kindly do. If you've been enjoying and you've been gaining benefits, please share and also follow. Thank you so much. Now, if you look at the board, you see that we have already a question that it appears we're already solving. Yes. In the last class, I was actually solving this question, which was show that the log of a, the log of b in base a, multiplied by the log of a base b is actually equals to 1. And now we're solving just about 2 or 3 steps for us to round up. And then something that happens in this part of my climb happened. The power supply went off. So I paused the video and I thought to go over it again and then finish up. Now, the thing is this, I'm not going to repeat the entire question by solving, but we'll just explain what we already have on the board and then finish it up. In other words, it's going to be a very brief video today. But let's go ahead. If you missed it, it's either you make do with this or you go to the previous video. And you also look at other videos on the things I've done. Thank you so much for doing that. Now let's go. Now the question started by saying show that the log of b in base a multiplied by the log of a in base b will give you 1. Now you now see this like the reciprocal. It's like saying that the reciprocal, the log of b in base a, the log of a number to a particular base multiplied by the log of its reciprocal is equals to 1. The reciprocal of the base and the actual number will give you 1. Now, when we have this, the solution is simply this. This will start the solution, and then we said we'll pick each one of them. We'll pick this, and then we'll pick this, and then we'll say let this, which is this, be represented by an alphabet. So we choose X, and then let this which is this, be represented by an alphabet which was y. Now, if we bring it, we'll say, therefore, that log in base a, log of b in base a is actually equals to this. And also log of b, this, and then the next one, which is the first part, and then the second part is this, which is this. We'll say log of this is equals to y. So log of this is equals to this, and log of this is equals to this. So by having this, we'll be able to form 2 different equations. Now if I pick the first one, which is this, and I said I use the definition of logarithm. Now what's the definition of logarithm? The log of a number to a particular base is the number of times the base will be raised to give that number. In other words, the log of x in base, the log of y in base x is the number of times, let's say it's equals to z, is the number of times the base will be raised to give that number. So what it's going to mean is this. It's going to be, the base is x raised to the power of z, x raised to the power of z to give us the number, to give us y. So in other words, y is the same thing as x raised to the power of this. If you substitute them with values, it's still the same thing. Let's say y is 4 and x is equals to, let's say x is 2. Let's say y is equals to 9 and x is 3. This will be actually 2. If you put it in a log like this, like the log of 9 in base 3 is actually equals to 2. If you solve it like this, you will get this answer. This thing is like this. So that's just the definition. Is maths, it's just like that. It's going to be okay. You get your question. Now, if we go by the definition of logarithm, we'll have this. So the log of b in base a is the number of times a, that is the base will be raised. So the base is raised to the power of x, which gives us this. And at the end of the day, we have this as an equation. Equation number 1. Then we pick the second part of it, which is this, is equals to y. That's log a in base b is equals to y. So if we do the definition of logarithm, the log of a in base b is the number of times the base, that is b, will be raised to give y, to give, a. So b is raised to the power of y. So b raised to the power of y will give us that number. The log of a number to a particular base is the number of times the base will be raised. So the base pushes this one up, so to say, will give us that number. That number is a. So having got this and realized this to be equation 1 and this equation 2, we'll solve them simultaneously. Now your lower levels you've heard of and you solved simultaneous equations. So we have to simultaneously solving. We choose the substitution method. In other words, we say we'll substitute b into equation 2. So since b is equals to a raised to power x, we substitute it, the value of b, into equation 2. What is equation 2? This is equation 2, which is what? A raised to the power, a is equals to b raised to the power of y. So wherever we see b, we substitute with what? Ax. So this is it. So b is equals to ax. We substitute b is equals to ax into equation 1 into equation 2. So what's the equation 2? This is the equation 2. Now this is equation 2. This is equation 2. So that means b here is actually equals to a raised to the power of x. You have it here. A raised to the power of x. So this b has been substituted by this, because actually from here b gives us what? B is actually equals to a raised to the power of x. So we removed, wherever we see b, we remove this b and put a raised to the power of x. At the end of the day, what we now have eventually is this: a raised to the power of x in bracket y, power of all exponents. Now this one means multiplication sign, and so if I remove this, this is going to be a times y, which is the same thing as a times y. So I like to put a dot here, or you may leave it. Now having had this, you come back again because you want to proceed. A is the same thing as a raised to the power of 1. If I take a number, 2 is equals to the same thing as 2 raised to the power of 1. 20 is the same thing as 20 raised to the power of 1. Anything, including alphabet, z is the same thing as z over 1. Y is the same thing as y over 1. Anything raised to the power of 1 is still the same value. So having had this, we proceed. So we put this to be equal to raised to the power of 1. To this end, we want these two to cut off. So they both cut off, we'll have one remaining. This is this. Now it's not looking like what we started with. What was A when we started? What was X represented by? X was represented by what? Log in base. Log of B in base A. And what was B represented by? Remember there's a times here, multiplication time, which is B. Y was what? Log A in base B. And bring this to a plus sign here, a plus sign here, and then a 1 here. So now say we return back to this place. So what we have, this is just the final step for the last class. So eventually, therefore, as we have it here, just to repeat it, just so repeat, y(x) equals 1. If we bring everything, we have log in base, log of b in base a multiplied by log of a in base b to be equals to 1. We'll be able to prove it that this now is a law, a reciprocal law, that the log of a number to a particular base multiplied by the reversal, the reciprocal of the number and the base will always give you 1. Check other questions solved. If you have a question, please put it there. If you have another question you think we should solve, please put it, let's see, at the comment section. I want to thank you for, if you didn't understand anything, please let me know too. Thank you for staying tuned. Let's see you in the next class.